All right, so we've seen this MMO architecture. Let's see another example today, and then we'll talk about a more in-depth, larger application on Wednesday. So let's kind of wrap up this MMO stuff. Today and Wednesday and last Friday even, we're not really covering any new concepts. There's no new concepts. They're all out there. All of level 3 is out there. We're just going to see, reinforce through examples what you already see. The biggest thing to take away from this whole level is this idea of an event-based architecture. We have a WebSocket server and WebSocket clients. They're going to react to certain events. We're going to get these messages and have some code that's executed when we receive those messages. And then on the actor side, we have the actor messages. We're going to receive some case class or case object as a message and run some code when that event or when that message arrives. That's the big thing, and then we gain concurrency through this, either over the network or through the actor system. We're gaining concurrency. We have multiple pieces of code that are effectively running at the same time, usually not exactly at the same time at the very low-level computer implementation, what's happening on our processors, but effectively, from our perspective, happening at the same time. So those are the big things that we've learned. So let's see some more examples of this. Most of the rest is just understanding the syntax of how to get that done in each application, whether it be buttons on a GUI like we saw, messages for an actor, WebSocket servers and clients, how to do that in different pieces of the architecture. So lecture question is kind of taking one piece of actors that we haven't really explicitly discussed. We just want to talk about this one quick for the lecture question. Is an actor that can create other actors. Is something we have to do for, not necessarily for Clicker, that's a socket server creating more actors, but this idea of creating more actors after the system is already initialized is something we haven't explicitly talked about. There's not much on it. I got like 2 slides on it later. It's not really different than what we've seen already, but let's talk about it explicitly. Create an actor that'll create other actors on certain messages and destroy those actors on other messages, and then send messages to those actors that it created. And we can talk about that a bit when we get to those few slides later in the lecture. Quick heads up for the lab. I want to try getting these lab descriptions out Monday. When I get them out Tuesday morning, it's really not fair to those Tuesday 8 a.m. students. So earlier in the semester, we saw a GUI where a user could click and place rectangles on the screen. We had those rectangles spin, and it was our first introduction to 2D graphics in Scala for Scala desktop. What we want to do for lab is add a database to that. So when the user runs the app and clicks to add some rectangles, and then restarts the app, all those rectangles when they click were added to a database, and then when you restart the app, it pulls from that database, pulls all of the rectangles that were saved, that were added in previous runs of the program, and displays them on the GUI immediately. So no matter when the program is restarting, the user still saves all of their rectangle locations. And it's fine for lab, they don't have to spin, we don't need any of that functionality. You don't have to remember the angle at which they were when the program closed or anything like that. Just remember where the user clicks, those rectangle locations, and when they restart, show those rectangles. So you have to have MySQL running, like I mentioned a few times last week. Have MySQL running, test it, make sure it works, make sure it does everything you need it to do, make sure you can interact with that MySQL database. What I really want to see from lab, what I'm testing for lab, is can you interact with the database? Can you store information in a MySQL database inside a table? And can you retrieve that information again? So once you have MySQL set up and everything set up, this shouldn't be too difficult for the lab. But if you don't have MySQL set up when lab starts, before lab starts, it might take you more than that 2 hours just to get MySQL set up in some cases, if you run into a lot of little issues. So make sure you have MySQL installed, running, tested before you show it to lab. The GUI itself, you can just grab the GUI from the examples repo. You just take that GUI. I'm not testing on GUIs on this one. You just take that GUI and use it out of the box. That's fine. But you have to plug in the MySQL code, the SQL statements to execute inside of that application. and I'll have the full document up by lab tomorrow morning. It'll say the same thing, just in more words and more exact descriptions and with a grading rubric. I have part of the grading rubric written. The most important thing to note on that one, I suppose, the TAs will be checking if you're actually using MySQL. If they catch you using something like file.io and saving the locations to a CSV file or something like that, it's going to be 0 of that. It's all about using MySQL, using that database, and moving on, graduating beyond file.io, moving beyond SQLite, and using a fully fledged SQL server, MySQL in this case. So just a heads up on that as well. You do have to use MySQL. All right, MMO, we've talked about this a bit in the semester, and you know some of it's coming up down the road. You know the project in lab is an MMO, but I want to take a quick slide to define an MMO. I got this question a few times last semester, where students just weren't familiar with MMOs, and it kind of dawned on me then, like, yeah, maybe not everybody does know what these are. So just a quick time out to talk about this. MMO stands for Massive Multiplayer Online. It very commonly refers to games. It's usually an MMO game, and then can have an acronym added to the end of it for the style of game. So if you've heard of it, MMORPG, that's a Massive Multiplayer Online role-playing game, which is probably the most common, I shouldn't say probably, it is the most common form of MMO games, where you have a lot of characters, adventurers walking around, fighting monsters, raiding dungeons, things like that. But MMO can be applied to just any game where users any app where users are interacting in real time, and where you don't have a strict cap on the number of players. So a lot of players can join this game, all using the same server and all interacting in a common world, in one world. This is where we get that massive part of it. We can have multiplayer online experiences that are just a few players interacting, maybe online poker game or any online card game like that, where you have like a max of 10 or so players. That's a multiplayer game or a multiplayer experience. But once we move to the massive, we want to get rid of that upper cap on the number of users, and however many users log on, all of those users can interact with each other. So that's what we're after with the MMO architecture. We want an architecture that scales up to any number of players. Within reason, of course, if you have 1 million players all logging on to your laptop's hardware, it's going to crash, it's going to lag. But within reason, there should be no software limitation on the number of users. So if you took that same software and distributed it across an entire server room, that your app would be able to work and support millions of players. That's what we want. So we'll see an example of this, an admittedly not very fun example. And on Wednesday, I'll just say today's example isn't posted online. Wednesday, my goal is to have one that's hosted online that we can actually enjoy, that we can all play. Trying to get there today, just didn't quite get there in time. So we'll see our first example of this architecture in use. It's in the examples repo. You can download it, host it, and play with it that way. But we'll see our first example. It's debatable whether the chat app is an MMO. Technically, I guess it does. So technically, our second example, but I don't know if anybody would use the MMO name for chat app or for social media or something. For my money, for me, the definition breaks down there where I want to see real-time interaction. A chat app is if you do have that 1 second delay like we saw last semester in 115, it doesn't really destroy the experience. Where I, in my mind, see it as an MMO is the real-time interactions, where if you have a few hundred milliseconds of lag, that it kind of destroys the experience of the app. So that's where I draw the line. So let's see this example. We want this very simple example where we can see each other's mouse movements. Not particularly fun, not super interesting, but it shows off the technology and shows off what we're doing here. So let's see. So first, it's going to be a lot of looking at code in IntelliJ like the last one was. If you have questions, please ask them, and we'll see how this thing works. So let me, oh boy. All right, bear with me for a second here. Somewhere in here I have a server running. I'm going to do something very dangerous and run this. Oh no. Boy. Apparently I don't. That was a false alarm. I don't know what caused that. It said port already in use, but I didn't have that port in use. So I have a web front end for this. I already have it open, as we can see here, I already have it open twice. Let's open it up a third time. And we can see mouse movements across both versions of the app. So I have this yellow dot on the left. I can see myself moving around the mouse. If I go to another tab, I control a different character. If I go over here, I can control this character. So I have 3 different connections, 3 different WebSockets. I'm controlling 3 different characters, and all 3 simulated here, but all 3 users can see each other in real time. So we can start seeing how we can build this out to a game once we have all 3 players on the same map, being able to see each other's actions, and being able to move around in a shared world and see those real-time interactions, or at least near real-time. There's a 1/10 of a second delay here, just the way I have the server set up, so I'm not using too much bandwidth. So 1/10 of a second, a little choppy admittedly. I could lower that to a 1/30 of a second. But we can see the movement. So that's what we're building here. Let's see how this works. Let's start, since it's already open here, let's start at the web front end. Since there's not a whole lot to look at on the web front end. Let's get this one out of the way. It's 3 files, but each file is pretty small. Here's my HTML. For this, I'm using a JavaScript canvas, an HTML5 canvas, and then using JavaScript to add elements to this to add to the canvas. So I have a canvas. I want to get rid of the cursor, and then just show the cursor through my JavaScript through the actual app itself, and then grab my JavaScript and grab the Socket.io library. So HTML, almost nothing, very minimal. CSS doesn't exist. Very simple on that front. And then we have some JavaScript to actually show the app itself. So here we want to set up our socket connection, just like we saw before. And I want to say on the game state message, whenever I get a message of type game state, I want to render that to the view, render that to the browser using these shapes and the canvas and stuff. So I'm getting the canvas, setting the height and width of the canvas for the boundaries of the game. And then when I get that game state message, I'm going to call my update, which you built this for, like I mentioned last time, you built this for demo 2 of the project. You have these update methods that take in a JSON string, parse it, and then display everything once. So I'm going to display, clear everything, and then display each user on the canvas just as a circle, and I have a method as a square. So I have my method to draw a square. And I have one extra piece of logic here. I'm going to check the player's ID versus my socket ID. the socket IDs are actually globally unique. So the socket ID on the client side is the same socket ID as the server. So I had the server send the socket ID attached to each player, and now I can have the user player, whatever user is in this window, to actually be displayed as a slightly different color than the other users. So I can tell which one I am. I'm always going to be the yellow one, and all the other players are going to be blue, that light blue color. So we can get that by checking the socket ID and avoid the use of, we certainly could, but to avoid the use of usernames and having everybody choose a username, this one I want it nice and simple, just start it up and you jump right into the game, and then we use that socket ID as a global ID for each user instead of having them register a username. So slightly different setup than we've seen in the other apps, in the chat app and in Clicker, but we get the same effect. We can identify the user for this particular instance of the game and then display just their avatar as a slightly different color when we render the view. So the game itself on the server doesn't care about the different players as long as they're marked as being different. And then when we go to the view to actually render, each individual view is going to say, okay, this player is me, display this player as a different color. And one more thing, we're going to use the mouse move. So same thing we did in ScalaFX. I want to grab a certain event type. JavaScript, same setup, same event-based structure here. I'm going to say whenever the mouse moves, call this code. So whenever the mouse moves, I want to grab from this event the X and Y coordinates of the mouse and send those to the server over the socket as a message of type location. Nothing crazy here. I'm just using an application, just applying what we know about sockets, applying what we know about event-based architectures, grabbing that event, and then sending it to the server. I have a little bit of extra logic here, just so we're not blasting the server constantly. I'm saying at least wait 80 milliseconds between updates, between mouse movements, because as I move around the mouse, it's going to constantly be firing this mouse move message. Just to reduce some bandwidth load and some server load, I'm going to say wait at least 80 milliseconds before sending this to the server again.
So it would still work just as something on it would just potentially be too much?
It'll still work, and it'll certainly work on my laptop, because I'm not actually doing any networking. But if for that part specifically, I'm thinking, I have a server, I have hundreds of users, thousands of users. I don't want them all just constantly blasting the server with these updates, because it might start getting bogged down, it might start chewing through my bandwidth at that point. So I had that extra logic to be able to do that. So I'm getting the timestamp, similar to what we did with system.nanotime, except this is millisecond precision. So I'm getting the milliseconds of the epic timestamp in milliseconds, and then doing comparison, checking my update intervals, updating the last update time. So similar to what you do in Clicker too, when you're updating, okay, here's my new timestamp, here's my old timestamp, what's the difference? Convert that to seconds, update my goal based on my goal per second, and then update the last update time. Similar concept here, I'm just using it for a different application to make sure I'm not spamming the server. And that's the whole front end, not too much there. Granted, it's a pretty straightforward game too. If you can call it a game, I wouldn't, but. Few other things, let's get these smaller ones out of the way and then we'll tackle the server. That's where most of the code is that server. So we have two message types, save we're not using, but one message type, update. Save, if we're saving to the database, there's really not much to save for this one, so I didn't end up using it. And then character object. Each character needs to know its X and Y position and a way to convert it into JSON so we can send it over the network. We always need to send JSON over the network. The network doesn't know what Scala types are, doesn't know what a character object is, so we're going to convert this to a JSON value before sending it. So for this, I want to know the X and Y, and also an ID which will be the socket ID for any player users. Anything that's going to be sent over that socket, we need to be able to check that ID to know which player to make a different color. So we're going to send the ID as well, and we're going to take that as an input to the JS. If a particular character doesn't have an ID, we're just going to default to nothing and not add that ID to this JSON. So we don't actually use, we'll always use an ID for this application, but it's something we could see. All right, now let's tackle the server. How does all that come together? And importantly, this is where an actor system and the WebSocket server come together. This is something we talked about. It's always in that image, but we haven't seen too many examples of it. Have you seen any? Maybe just the clicker. Oh, do we see a socket server that creates actors yet? I don't think so. So here we're going to set up the actor system. It happens to only have one actor in it, but we can see from what we know about actors that we could create more actors. We could add to this more actors to expand the functionality. So we're going to create our actor system, create our actor of MMO server, and we're going to have 1/10 of a second resolution, 10 frames per second, and every 1/10 of a second, update all of the users about the new locations of every player. So that's our system. But what did we actually create there? We created an MMO server, which is an actor, but it's also going to have a socket server. It's also a socket server. So this is a socket server that's also an actor. So we can add it to an actor system and send messages to our other actors in a larger system, but can also listen for network traffic. So this will be our linchpin between a WebSocket server and our actor system that, as we saw in the architecture, kind of the controller of the entire app is going to be located here. And then the model can be in the actor system, can interact with the database, and have a lot more functionality over on that end. So here, we're setting up our socket server. I want to know whenever somebody connects, disconnects, or sends me their location. These are the three things that we want to interact with each client, with each user. So when we connect, I'm going to start everybody at location 00, and remember that socket associated with that character. So now when I get messages over this socket, I know which character to update based on that socket ID. So I'm going to map sockets to that new character, and then when somebody disconnects, I'm going to remove that socket and character from my map. So this map, socket to character, just like we saw for the chat app, I'm going to have a map that's mapping mapping the socket WebSocket that I'm getting data over, that I have a client connected to, and mapping that to some object inside this system, inside my app, that's going to be associated with that WebSocket. So I have a WebSocket, somebody connects, I'm going to create this character object in the app for them, and I'm going to link them. I'm going to make sure that that socket is affiliated with this character object, and I'm going to remember that through this map. So whenever I get subsequent messages over that socket, which will be the location and disconnect, I know exactly which game object, which character object is associated with that. So connect, add them to that data structure, disconnect, remove them from that data structure. Whenever I get a message of type location, I'm going to have, and I should mention this here too, I'm going to have my little checks here just to make sure that this socket is in my data structures, or else something went wrong there. This shouldn't be an issue here since we're using connect and disconnect instead of register and disconnect, but still, I like having my checks in there sometimes. I'm going to get the character associated with this socket, get the location from that JSON message. They're going to send me that X and Y in a JSON string, and then update that character's X and Y based on the values that I pull from that JSON string. There's always be ints because we're working in pixels for this particular app. It's all pixels. So how many pixels, what's the X and Y location in pixels? Update that character. Then every 1/10 of a second, we're sending this update to our server actor as an actor message. And every time we update, we just want to broadcast to everybody in this case the current game state, which is going to have every... I'm trying to get this on. No, I can't get this on screen. Which is going to have every player's JSON location with ID. And that ID, we're going to pass that argument and set that ID to the socket's globally unique ID. So I send them the ID. That character object is going to give me its X and Y, add that to the ID to the JSON value, and return those JSON values using this, again, using that map method that we saw last time. That's going to take a function. I'm going to map this function, apply this function to all of the keys in this map, which are the socket IDs. I'm going to use that key to access the character object right here, call its as.js value, and access its socket, the socket ID for that particular player. That's going to give me a list of all these JS values. I'm going to put that in a map, all the players, mapping to that, and convert that to a JSON string. So I have a JSON object with one key called players, which maps to a JSON list of objects, and each of those objects has an X, Y, and an ID. So that's what I'm sending as my game state over to each client, and that's the same format that my clients are expecting when they receive that message of type game state. They're going to parse it, access the value at key players, and for each player, we're going to access the X, Y, and ID to figure out how to render all these things to the screen. And that's the whole app. So beyond that, so this is all the structure of how we would set something up like this that's going to connect the actor system to a WebSocket server to a WebSocket client. Beyond that, it would be actually building out whatever you want to build based on this. So we have a way to capture inputs from users, send it to the server, or the server share all this information, send it to all users. After that, it's whatever we want to do that you've been learning for the last semester and a half. All that programming knowledge you can throw into this thing and just build out more and more. Are there any questions on this example? And hopefully this stuff is starting to sink in. The more examples you see, hopefully it's sinking in a bit more each time.
So in JavaScript for the game state JSON function, so this is the for loop here. This was the what players or objects to all the applications. But in Scala here, obviously, what's that line doing?
This line right here you're talking?
That's through every single player.
Yeah, so that's going to go through my socket to character map. It's going to loop through every key in here, every socket IO client in there. So it's going to look at every single socket, access the value when it says socket to character. So I'm going to iterate over all the keys in this map. For each key, I'm going to run this function that takes in a socket IO client, which is the type of the keys.
Oh, I get what, okay, that's the map.
Yeah, this is a function that I'm calling on every single key in this map. So this function takes in the same type as the keys in the map, and then for each key, I'm going to access the value from that map, call its as.js value method, which was this method that we saw earlier, to convert it into a JSON value. And I'm going to pass that socket ID to it. So in this function, I need access to both the key and the value from this map. So I'm accessing the key, getting the value, and then from that key, that socket, I'm getting its ID. which is that ID that's going to match what the client has for its ID. So it can say, does this ID match my ID? If so, make this circle yellow instead of blue. What are the other ones? I forget. Does that make more sense? And in the next 3 weeks, we're going to see a lot more of this type of syntax. I'm kind of sprinkling it in every now and then, but once we get to, I think we come out right out the gate next Monday, explaining this more in depth and what's fully happening there. Right now, I'm just trying to sprinkle it in there so we can get used to that kind of syntax, and we'll see more in depth of how this is working and what it's doing in the following 3 weeks. Yeah, this is definitely the most complex line in this app, for sure. It's kind of a beast. Any other questions on this? This session ID is, so this is going to get, let me pull something up here. Wait, I don't have to do that. I can try something new here. Don't exactly know how to do it in this browser yet. All right, let me just do my console.log. So when I want to make the current player yellow instead of light blue, I'm checking that socket ID. What that get ID is doing for me is getting this exact ID for the socket. It's returning that unique ID for that socket, which is guaranteed to be unique across all the sockets connected to that server. So I'm pulling that ID and adding it to the JSON string. So then in the JavaScript on the client side, I can have this line that says, if that ID that you're sending me over the JSON string is equal to the ID for my socket, make this a different color. So I'm using that as a way to tell, is this the player that's associated with me? If it is, let's do something. Let's handle this a little bit different. So when I check this socket.id for this socket, it's going to be exactly the same as the session ID for the socket on the server. Those are going to match from server to client. So it's a convenient way that we can have this information shared across server and client. Any other questions? Hopefully this stuff is making more sense these days. Yes, question.
When you send a broadcast, what's the difference between
Sorry, what was that? When you send a broadcast,
what's the difference between emit and send broadcast?
And so the question is, what's the difference between emit and the send event, right? So send event, that's just what this particular library decided to call that. It has the same functionality as emit. So even if we did, like when we wanted a single socket, we don't actually have an emit method just because the way this database in particular is set up. It just doesn't call it emit, it'll call it send event. So it's just a library difference. But it has the same exact functionality as emit. So when we're in a Scala GUI or a JavaScript GUI, that we're going to use emit because that's what those libraries call that method. And also different servers. This is one thing that bugs me. I don't know why this particular library does decide to make that a different name, but I mean, it is what it is. There are other servers in different languages, other Socket.io server libraries that still call that emit. So I don't know why this one did send event, but it's the same thing. You can think of that as emit. Is this Java? This is Scala code. Java does not equal JavaScript is very true. The analogy goes, Java is to JavaScript as car is to carpet. They are completely different languages. Same can be said with Scala. Scala is very different than JavaScript. Scala is much closer to Java. All right, if there are no more questions on that one, let's take a look at some Clicker. So I know this is what's going to be on everybody's mind right now. By the way, there's a stunningly low number of submissions for Clicker, so if you haven't started on this homework, please do. It is a large homework. It'll be, I think, comparable to calculator in difficulty. It's a different type of difficulty, but it's up there. It's definitely not an easy assignment. That said, unless you have a firm grasp on actors, both actors and WebSockets. Once you have a firm grasp of both those topics, it's not too difficult of a homework. But since I know those topics are very new and very different from anything you've ever seen, that's going to make it a pretty substantially difficult homework. So just, if you haven't started working on it, if you haven't gotten to your first submission yet, which I know the vast majority of you haven't, just looking at Autolab, please get there. Start working on this. So let's look at this architecture a little bit and see how our architecture is being applied to the Clicker game. So this isn't strictly an MMO because users are not interacting with each other, but every single user does have its own actor in this system. So I just had the starter code, so you're not getting any extra information here. But let's look at the starter code and kind of explain what's going on, what we expect to be happening here. So our Clicker server is an actor, and it's going to be a WebSocket server. It's going to start a WebSocket server, localhost port 8080, and listen for WebSocket connections, send WebSocket connections. It's also an actor, so it's listening to actor messages, and it can send actor messages to all the other actors in the system. And what we want to do here is listen on the WebSocket server for registrations. Whenever a user registers with a username, similar to what we saw in the chat app, we want to create a new actor for that user, which is going to be of type game actor that you build in Objective 1. Create that new game actor, add it to the system using that props and actor of, right here. Using this same syntax, we want to create a game actor for every user who logs in, who registers over the WebSocket, and then over the WebSocket, those users are going to be sending us click gold and buy equipment messages, and we want to translate those into messages for that game actor, send them messages of click gold, buy equipment, and have the game actor process those for each user. And then when they update, they're going to send back to this server the game state of each one, and we want to send that game state to each WebSocket user. So this is the linchpin between all of our users who are connecting through WebSockets and our actor system, which is the model of the game, which is actually running the game for each particular user, one game actor for each user. The game actor, I should have went in order of the objectives, but it's too late for that now. The game actor, it's going to be an actor in our system, one game actor for each user who's currently logged in. And this is going to listen for those signals. It's first going to initialize the game. For Objective 3, it'll connect to the database and say, hey database, do I have a saved game for this username? If so, it sends that game state back and you load the game on that For objective 1, this is going to initialize the game with no equipment, no gold. Listen for messages type click gold, and listen for messages of type buy equipment, and have the appropriate actions for that. For click gold, go through all the equipment, sum up all of the gold per click values, add 1 to that, because you always start with one gold per click. Add 1 to that, and then add that amount to your gold total. And whenever you get the buy equipment message, look up the price of that equipment by ID. Look up the price. If you can afford it, decrease the gold, increase the number of that equipment currently owned. And then for the update message, you're going to get updates and say, this is the new, update your game based on the current time. And then check how much time has elapsed since the last update, and add that, convert that to seconds, and add that based on the total gold per second of all your equipment, and add that to the current gold. So a few things that have to happen here to build that basic functionality of the game that you saw when you built the front end in lab. And I mentioned this before, it's worth repeating. If you have a front end, especially if you know it works and it's pretty good, feel free to share those front ends, those web and desktop front ends that you built in Live. Feel free to share that with other people so they can test their game as well, that they can use that to test. Having that GUI is going to really help when you're working with the server. And if anybody doesn't have, if you don't know somebody with the GUI, contact me, post on Piazza, do something. Make sure you have that way to test, or build your GUI if you didn't finish that lab. Build your finish your lab too. Be a good idea. Come to office hours. There are a lot of options here. So that's kind of the architecture of this. It's the idea of what's going on. We have this Clicker server, which is the linchpin between WebSockets and actors, and the actor, which is going to maintain each game. So a bit of data structures to handle, a bit of different message types that you're receiving to apply all these concepts we've been learning over the past 3 weeks. So there's one thing we just got to make explicit here. In here, we're talking about an actor creating other actors. That game server has to create other actors. Each time a user registers, it has to create more actors. So how do we do that? Well, initially, this is what we did. We created a system and then just added actors to that system. But we're only going to create one system per act. There's only going to be one actor system. So how do we add actors to an actor system through an actor that's already been created and initialized? So the answer isn't too crazy, but something I think I forgot to have a slide on earlier. I think I neglected to do that. But it's very straightforward, nothing to really explain here. We're going to use the context variable. So if we're inside an actor, this.context, and then we're going to use that the same way we used system earlier. This.context, actor of props, and anything else we need to create an actor. It's going to return an actor reference, and we can use that reference later on. So inside that game server class, whenever we get that register message, we want to say this, or rather server.context. Server, because you're not going to be inside the actor for that. You're going to be in your listener class. So pass a reference of your actor. Context, actor of, props, class of, game actor, username. You can create that actor and add it to the system from another actor, or rather, whenever you have access to an actor ref of an actor that's part of that system. So whenever you have access to an actor ref, .context that thing, and then you can start adding more actors to the system through that actor's context. You have access to that system through each actor. To destroy an actor, this one I did show, but I showed it in passing earlier. Send it the poison pill message. It's a case object that's built in the ACA library. So you import it from the ACA library. Send it the poison pill, and that says, hey, actor, just disappear, just go away. So send it the poison pill, and that's going to end that actor. If you don't send the poison pill after you're done with an actor, it's going to sit there chewing up resources. You're going to have memory leaks. It's bad business. So send it the poison pill when you're done with it. So when somebody disconnects from your Clicker server, send that actor, that game actor, the poison pill, say you're done. And then since it's saved into the database once you have the full game, next time that user registers, they'll actually get their game loaded from the database. That's going to have the last update timestamp on there. And then next time you send an update, it's going to have this large gap in time that it's going to update all your gold per second based on that. So our users are going to get that idle income when they weren't even logged in. Bring us back to the lecture question. All right. Oh, we're a minute past. All right, so with that, everyone